All right, y'all. So here we go. 6.8. Like I said, does increasing, decreasing. And piecewise functions. So we looked a little bit at the increasing and decreasing the other day. Um, so we'll do some problems with that in a little bit, but they start out with the piecewise functions. So y'all, let me tell you what is a piecewise function. So y'all, a piecewise function is a set of equations in which the domain determines which equation is used to find the function value. Okay, so they'll give me two or more equations, and they'll give me a domain after each equation. And depending on the function value, that's going to determine which equation I use, okay? So I'm going to give you all an example before we sort of do some of those homework problems they got. So I'm going to make a set of equations based on somebody making $20 an hour, okay? Because if you get paid by the hour, anything up to 40 hours, you multiply the amount of pay times how many hours you worked. But if you work more than 40 hours, you get overtime pay. So you would use a different equation to find your pay if it was more than 40. So y'all, I'm going to call this P of T. So P stands for my pay, and T is the time in hours. Okay. So I said we made $20 an hour. So to figure our payout, we would take 20 multiplied by how many hours we worked, and we would do that for any T that was less than or equal to 40 hours. So if I work less than or equal to 40 hours, I'm going to use this equation, plug in for T to figure out my pay. Now, say I work more than 40 hours. The equation for pay would be 800, because that would be $20 an hour at 40 hours. So you'd get that 800, plus you'd get your overtime. Well, overtime is time and a half. So time and a half times of 20 would be $30 an hour. And then that would be your T minus 40. So what that means, if you work 43 hours, 43 minus 40 would give me 3 hours at $30 an hour, plus my 800, which was 20 for 40 hours, okay? So I would use this for any T that was greater than 40 hours. Okay, so that's a basic set of equations for someone working and making $20 an hour. So for my first question, which equation would we use for finding P of 25. Now, they start out, they don't want you to figure out the amounts. They just want to know which equation would I use to find P of 25. So I've worked 25 hours. So I would look at these domains. So 25 is less than or equal to 40. So since that's true, I would use the first equation, which is 20 times T. Okay, so they just want to know which equation. They don't want me to figure out how much. But if I wanted to figure out how much, I'd put 25 in for T, multiply that and see what I get, okay? Now, which equation would we use for finding P of 47? So now 47, that means we worked a little overtime. So we come up here, 47 is not less than or equal to 40. So I look at the second equation. 47 is greater than 40. So since that's true, I would use the second equation, which is 800 plus 30 times P minus 40. Okay, y'all, so these first three problems we're about to look at, I'm going to show y'all the problem, and we're just going to figure out which equation we would use, okay? So I'm going to share my math lab now. And y'all, let me bring this to number 1 here. So y'all look at that. They're giving me a piecewise function. F of x equals x squared if my x is less than -2. F of x will equal 7x for -2 less than or equal to x less than 4. And then I would use the last equation, x minus 4, for any x's that are greater than or equal to 4. So they want to know which of those three expressions should be used to find f of -9. So you got to figure out, is -9 less than -2? Is -9 in between -2 and less than 4? Or is -9 greater than or equal to 4? So y'all knowing those three domains, what are y'all picking? A, B, or C to find f of -9? So what are y'all saying? C? Yeah, because -9 is less than -2 for sure, right? -9's way out to the left. So since -9 is less than -2, we would use the x squared equation, which is definitely C. So y'all, you would check that. So let's look at this one. We're going to find f of 7. So we use the x minus 3 if x is less than -5. We use 8x if -5 is less than or equal to our number less than 1. Or if our number is greater than or equal to 1, we use the x squared equation. All right, y'all, so find me f of 7. Which equation would y'all use? All right, y'all, let me write this one down real quick. So what I got, f of x equals x minus 3 for x less than 5, or less than negative 5. It's going to equal 8x for negative 5 less than or equal to my x less than 1. And then it's going to equal x squared for any x greater than or equal to that 1. And then we're finding what, f of 7. Oh, y'all, so remember, f of 7, you got to come over here and figure out where does that 7 fit in these 3 domains we're giving you. Okay, so this stuff on the right side is just for the domain to figure out where your number fits. These 3 are the actual equations. So y'all are starting to say C over there, so let's see. So 7 is not less than negative 5. 7 is not in between negative 5 and 1. 7 is actually greater than 1. So we would use the x squared equation. So y'all, let's go see if that is actually C like y'all are saying. Oh, y'all watch out now. C over here has, C is x squared. Yeah, so notice y'all, the equations are in order over here, but these answers are out of order. They got B and C mixed up, so whoo, be careful on that, okay? Um, they're not always in the same order as the equations are. So it was a third equation, but they got that marked as B for us, okay? So y'all be careful on that. All right, so y'all, we got 3 equations. It equals x squared if your x is less than negative 4. It equals x minus 3 if your x is in between negative 4 and equal to it and less than 3. Or it equals 6x if your x is greater than or equal to 3. So we're finding f of 3. So y'all be careful, because although the second equation is negative 4 less than or equal to x, the x still has to be less than 3. So if it equals 3, you want to use this last equation, because that says x can be greater than or equal to 3. So we would use the 6x equation. And y'all, once again, they got them out of order over here, but 6x would be our, what do y'all got? B equation. Good job. All right, now, so y'all, the other day we started playing with this intervals of increasing and decreasing. So let me go to my notes real quick and refresh this. So this will be decreasing, increasing, and constant intervals. So the new one is the constant, okay? We've already played with increasing and decreasing. So let me just define all these again. So decreasing are the x values for which the graph goes downhill from left to right. Okay, so we're looking at left to right. These graphs are going to go downhill. And remember, we're only concerned with x values, not the y values, okay? Increasing. Those are the x values for which the graph goes uphill. From left to right. So it's going to go uphill for increasing. And you always read graphs from the left to the right, okay? So y'all, the new one is constant. Well, constant is when the graph is horizontal left to right. So we want the x values for which the graph is horizontal from left to right. So y'all, that means it's going to go straight across. All the y values had the same value, so we called it constant, okay? So decreasing, they'll go downhill left to right. Increasing uphill, constant, it'll go straight across like a horizontal line, okay? Now remember, we're only concerned with the x values where it starts and ends on these intervals, okay? So we're going to go look at these graphs and see what we get. So y'all, let me make my graph just a little bigger here. So they want to know the function is increasing on what interval? So y'all, that's this third little section over here where it's going uphill with the arrow to the right. So what I need to know is what is that x value where the graph stops being flat and it starts going uphill. So if we look down, that looks like what? 1, 2, 3. So at 3 on the x-axis, it starts going uphill, and the graph is going uphill as I head to the right towards infinity. So we want the one that goes from 3 to infinity. Now remember, these got to have parentheses on the intervals. They can't be the brackets. So the only one that goes from 3 to infinity with parentheses, we would pick D. Okay? All right, y'all. Then it says, hey, the function is constant on what interval? So where does the graph start being flat, going left to right, and where does it stop being flat? So y'all, I'll give y'all this one, A, B, C, or D. Now remember, these can't be brackets, so you might as well throw out A and D, okay? Those points can't be both downhill and constant or constant and uphill. So we always use parentheses, remember. So it's either starting at at 2 going to 6, or is it starting at -3 going to +3? So y'all, let's go up here and look at our graph. Where does it start going flat? If I go straight down to the x-axis, that looks like it's starting at -3 right there where my cursor is. Now I'm following the x's to the right. I'm going to keep going to the right until I get to the point where the graph starts going uphill. That looks like a +3. So from -3 to +3 on that x-axis, so we would pick C. All right, then we're going to check that answer. So you know now they want decreasing. So y'all, the left side of this, although that arrow's pointing up to the left, that's not the direction the graph goes. That just lets me know that this graph goes on forever to the left side, okay? So my x's are coming in from the left side somewhere. So y'all, we say they're coming in from negative infinity. As we go down this x-axis, the graph is going downhill until I get to this point where it started going flat. So if I go down to my x-axis, that looks like that point is -3. So this graph comes in from negative infinity until it hits -3. So y'all, that would be D. Now C is close other than they got that bracket there, okay? All right, y'all, so let's look at this one. So notice, they want to know what intervals is it increasing. Well, I got this big long section that's increasing, and then the very last section is increasing. So you got two parts of this graph that are going uphill from the left to the right. So what I need to do is play with this first one first. It starts down here at this point, so I'm going to go up to my x-axis and see where that point's starting at. So y'all, you see it right there? So let's see, that's -1, -2, -3, -4, -5, -6. At -6 on the x-axis, this graph starts going uphill, and I'm going right down the x's until I get to this x value where it stopped going uphill. And that x value is 1. So we know the first line on here is from -6 to 1 on the x-axis. So then look over here, this last section is going uphill left to right. So I need to figure out where this dot is if I go straight up. That looks like it's hitting me at about 7 on the x-axis. And y'all notice, if you go right 1, so this one only goes through one x value, it looks like. But that second point on that line is hitting me at 8 on the x-axis. So that one goes from 7 to 8, the graph is going uphill. So we had the left side from -6 to 1, and then the right side from 7 to 8. So y'all, that would be C on that one, okay? All right, y'all, so let me make this a little bigger so that y'all can answer this one. Y'all just got to fill in where it starts going downhill and where it ends going downhill. And y'all, looks like this third line here is the only one going downhill. So where would y'all say that starts at on the X's, and where does it end at on the X's? So y'all, let me see. I'm not. So I'm getting what? Oh, Nat, you started me right. So I'm gonna take that 3 for sure. I'm gonna take the 3. But remember, from 3, you're going down to X's. So you go to 4, 5, 6. Actually, it looks like one more over. And y'all, I think that is actually 7 instead of 6. Because remember, that's the one where that other one started up there. So it would actually be from 3 to 7 on that one. So that, remember, don't look at the y values, only look at the x's on that x-axis, okay? So y'all, where is it constant? Constant is that straight line right there. The very first line is constant going straight across. We need to know where that starts and where that ends going left to right. So y'all, the solid dot, if you come straight down to the x-axis, ooh, that looks like what, about a negative. And Jackson, I think you was right. You just forgot your negative signs on that. So I'm looking at, yeah, so I'm looking at -8, like y'all were saying. And then it just went right twice. So that would be what, -6. And y'all, that's the whole trick on these, to stay focused on the X's only, okay? Now this one wants us to use commas to separate each of the intervals on it. So increasing, I will say there's two parts where it's increasing. The left side of the upside down U, this left side is actually increasing. Although that arrow's heading down, that just means it goes on forever. So that very first section is definitely going uphill. And then on the other side of the flat line, it starts going uphill again. So let's start with this left side. Those X's are coming in from the left side. So y'all, we say that's coming in from negative infinity. So we would put our negative infinity first, and then comma. So it's coming in from negative infinity. You're cruising along the x-axis till we get to the peak of that little parabola. So the peak occurs at -7 on the x's. Now, we put a comma, and it wants us to do the next section where it's going uphill. So y'all, the next section is this little line where my cursor is moving. So down here, right at the end of the flat line, it starts going uphill. So I'm gonna go straight up and see what I am on the x's. And y'all, that looks like I'm what, -1. I'm at -2 for that one. And then it goes uphill to where it starts getting flat again. So if I go straight down, that looks like that's hitting me at -1. Okay, so only focus on the x's. So decreasing. Y'all, there's only one part where it's decreasing and going downhill left to right, and that's the right side of that parabola. It starts going downhill there. So what we need to know is what is the x value of that vertex? So there's my vertex. If I come straight down to the x-axis, so it looks like a -7. Good job. And then let's see, we're going downhill as we go 2 units to the right. So what you got, -5? Good job. So y'all, that only had one part going downhill. So that'd be the -7, -5. You'll check that answer. Next will be our constant. So I'm going to start with the one on the left side first. So you got to go in order, left to right now. So the flat line here, we want to know what x value does that start going flat. And then where does the first line stop going flat at? All right, y'all, so I'm going to start on the left side here. So I'm getting -5, and then that'd be 4, 3, -2. Good job. So that's -5 to -2. And then we're going to comma, and then y'all got what, -1? And Jackson, that's so good. It does start at -1 there. So let me start that at -1. But Jackson, remember, that graph goes on forever. So it's passing through that and going to, oh, what y'all got? Infinity. There you go. Now, if that line would have stopped there at the 8, we could have said that. But remember, it's got an arrow on it. So that's telling me it keeps going and going and going. So that is headed off towards infinity. All right, y'all make this one bigger. So we sort of played with maximums and minimums. So this graph, do you have a relative minimum or a relative maximum? Well, it's a mountaintop. So we got a maximum. So we would click maximum on that. But y'all watch this. It says the relative maximum occurs at x equals, well, they're giving us this point up here. So the x value is what, a -5.5. And then it has a value of, well, remember the values are the y values, which is a 3.25. So once we say whether we got a min or max, we tell it what x value it happened at and what was that maximum y value, which was 3.25. So that one they're actually giving you the point in those parentheses, okay? So now, y'all, what interval is this function increasing? So where is it going uphill? Well, y'all, that's the left side of this graph here. The left side is going uphill, left to right. So you're coming in from the left, you're going uphill until we get to that x value. Now we know what the x value is. Oh, Nat, you're so close, but that, so I want negative infinity for sure. But what's the x value of that point? Hey, yeah, remember the x value is the -5.5, so we want to go with A on that one. Okay, so always ignore the y stuff when I'm looking at those. All right, y'all, so it's going to ask us for decrease, and let's see what y'all say. So decreasing is the right side of the graph going downhill. So I want to know what x value that starts at, and then where is it headed towards? So y'all got A, B, C, or D. So now I got what, -5.5? Yep, because if I come down at -5.5 and I'm headed right, you got infinity. Perfect. So we would go with A on that one, okay? You know, that's the main thing. A lot of this homework is just really just playing with the intervals here. And we really just trying to get y'all to realize that we only look at X values when we're looking at the intervals. The Y value just tells me what those min and max values were, okay? All right, y'all, this is going to ask us both of it. So they want the maximum first. Well, the maximum is this first point on the first little hump here where it's going uphill. That's my little maximum for that section. They're giving me the point is -2, -1. But notice how this one is. This one's backwards from while ago. This one, they want to know what the relative maximum is, and then at what x value. So y'all, for us, it's -1. That's the maximum value. And that happened at our x value of a -2, okay? All right, so what are we putting here, y'all? There's the minimum, that little valley right there. That's the little minimum for that section. They're giving you 6, -33. So my relative minimum is the -33. And that happened at the x value of, what's that, +6. Okay, so notice the question before they asked for the x's first and then the value. This one, they asked for the value first and then the x's. All right, y'all. So y'all got A, B, C, or D. Where is this increasing? Now you got two spots this thing's going uphill left to right. You got this first little section. So this thing is coming in from the x-axis from the left side. And this graph is going uphill until we get to that x value right there. So y'all, the first section, what do you say? That's coming in from what and going to what? Then you got this last section over here going uphill. So we know that point was at 6, -33. So where does it start and what's it headed towards? So let me see what we got. So you're good on the first part, -infinity to -2. And then the second part, y'all got what? C, so that's good. So that's going from 6 on the x's as you head towards infinity. So good job, y'all. That is definitely C on that one. So you know what they're going to want is decreasing now. So we're decreasing from the peak of one of these parabolas to the valley down here. So A, B, C, or D for our decreasing. Where does that thing start and where does it end? So what are we getting? A. So y'all, let's see. That starts at -2 there. And it ends at 6. Good job, y'all. That is definitely A. All right, y'all. Did let me write this next one down. Um, okay, so we had one more of these. So let me make this one bigger. Now notice this one, all they want to know is the relative max and relative minimum. They're giving me 4 answers. Now look, we do have a maximum that first point and a minimum at the second point. So you can throw out C and D for sure, because that one said it had no minimum on C, and then D said it didn't have a maximum. Well, it's definitely got both, so it's got to be A or B. So the question is, do I have a maximum of 1 at x equals 0 and a minimum of -3 at x equals 2? Or do I have a maximum of -3 at x equals 2 and a minimum of 1 at x equals 0? So y'all, what are y'all going with that? A or B? So let's see, Jackson and Nat, y'all got A. Good job, because that first point, when x is 0, has a y value of 1. So I got that. And then the second point, that's what, a -3 at x equals 2. So good job. It is definitely A on that one. All right, y'all, let me write this one down and then we'll work this one by hand. So this is number 9, g of x equals. So this is the piecewise functions again, but now they want us to actually find the function values, okay? So we'll use x plus 9 for any x's less than 4 or equal. We'll use 6 minus x for any x's greater than 4. So y'all, we're going to find g of negative 1, g of 4, and g of 8. All right, so let me show you how I do these. And they're not too bad. You just got to play with them domains. All righty, so we're looking for g of negative 1. So the first question I got to figure out, which one of these equations would I use? Y'all, will we use the x plus 9 equation for negative 1, or will we use the 6 minus x equation for negative 1? And I'm giving you the domains here. So y'all are saying x plus 9, good job, because negative 1 is less than 4. So we're going to use the x plus 9 equation. In place of the x, we're going to put our negative 1. And y'all, negative 1 plus 9 gives us a positive 8. All right, then they want us to find g of 4. So the question is, will I use the x plus 9 or will I use the 6 minus x to find g of 4? So, yep, looks like the x plus 9 again because of that equals. So 4 is less than or equal to 4. So since 4 is equal to 4, I got to use the first equation again, which is the x plus 9. I'm going to put a 4 in for the x. And y'all, 4 plus 9 will give us 13. So then they said, find me g of 8. All right, so which equation for g of 8? Y'all want to use the first equation or the second equation? Oh, that's pretty quick. Y'all want the 6 minus x? Because y'all, if you put an 8 into that, 8 is greater than 4. So we'll use the 6 minus x. So that'll give me 6 minus 8. And y'all, what's that? A negative 2 on that one. So find which domain you fit in and then use that equation, okay? All right, y'all, so this you just put your answers in as you get them. We had an 8 first. Then we came back and said G of 4 was 13. Then we said G of 8, we got what, a negative 2. So y'all, what if we up it a little bit on this third one here? So y'all, this last one here, h of x equals, now you got 3 equations. Negative 5x minus 14 for x less than negative 3. It equals 3 for negative 3 less than or equal to x less than a positive 3. And then it equals x plus 9 for any x is greater than or equal to 3. And y'all, they got 4 on this one. H of negative 8, H of 2, H of 3, and finally H of 4. All right, y'all. So I got my information written down. So we're starting with h of -8. Hey, y'all. So figure out which one of my domains I'm in for which equation we're going to use. So y'all are saying what? -5x minus 14, because -8 is less than -3. So y'all put a -8 into that and tell me what you get. Right? So negative times negative makes that of what? 5 times 8 is 40 minus 14. Ooh, what's that? 40 minus 14 looks like 26. All righty. How about h of 2? So which equation are y'all using for h of 2? Now here's the thing about this one. Anything between -3 and less than 3 equals 3. There's not a variable to plug in. So that means h of 2 automatically equals 3. That's one of them little constant parts. So anything in that section there from -3 to 3 is just going to be a straight line going across equal to 3, okay? All right, y'all, how about h of +3? Which equation for h is a +3? So that'll be x plus 9. Good job. So put a 3 in for the x. That'll be 3 plus 9. So that's what? 12. And y'all finally, h of 4. So for h of 4, which equation? So what y'all got? X plus 9 again? Yep, because it looks like anything bigger than 3 and equal to it, I'm using that equation. So that'll be a 4 plus 9, and that'll give us 13. So those ain't bad, and they usually go in order through the equations, okay? Y'all just remember, anything in this interval equals 3. There's no variable to plug in. It automatically just equals 3, and you move on, okay? All righty, y'all. So questions on those? All right, y'all. So we're going to take our break, and then we'll come out and knock out 5.4, okay? So I'm going to stop my recording here. And 5.4 is not too bad. It's got a little bit of tedious work on it, but it's only like 5 problems. So let's do our break till 11, and then we'll come back and we'll knock out our 5.4, okay? And that'll be the last section for test 2. All right, y'all. See y'all at 11. Also showing 11 o'clock, so I'm gonna get us recording and we'll knock out 5.4. All right, so 5.4 deals with complex rational expressions. And y'all, really, the only thing we're learning in this section is what we call the difference quotient. And y'all, basically, the difference quotient is what we call a modified slope formula. Okay, so it is f of x plus h minus f of x all over h. Okay. So this would be like your y2 minus y1. These are remember, I can use f of x notation instead of y. So this would be like my y2 minus y1. And then h would be the difference between x2 and x1. Okay, so h is just the distance between the x2 minus x1. So basically, this is a modified slope formula. So what we're going to do, we're going to be doing what we call constructing and simplifying. So I'm going to give you the steps to construct and simplify. Now, they're going to give us f of x, and it's always got h on the bottom. So really, the first thing we got to do is find f of x plus h. Okay, once we find f of x plus h, we're going to plug everything into the formula. So plug everything into the formula. And when I put them into the formula, I'm going to be using my parentheses, okay? I'll put my f of x plus h here, my f of x here, and it'll have the h on the bottom, okay? So the first thing we do, we're going to combine like terms on top. After dropping the parentheses, and distributing the subtraction. Okay. So we're going to combine like terms on top. Now, what's really going to happen on top is all terms without an h will cancel out. All right, so everything on top is going to cancel out if it don't have an h in it, okay? So at this point, the last thing we do is simplify the result by dividing all terms on top by the h on the bottom. Okay, because everything that's left, we said will have an H in it. So they will all divide by that H on the bottom, okay? And that basically will be the last thing we do is divide everybody by that H. So let's play with one of these. So for f of x equals 6x minus 4, we're going to construct and simplify the difference quotient. Now, they'll give you the formula every time. F of x plus h minus f of x all over h. Well, they gave me f of x right here, so that's going to go in right here to 6x minus 4. What we got to find is f of x plus h. So for the first we're going to do, we're going to find f of x plus h. So to find f of x plus h, we take our original function, and where they got an x, we're going to put in x plus h. So that's going to give me 6 times my x, which is x plus h, and then minus 4. So let's simplify this, and then we'll plug it into our formula. So y'all, to get rid of parentheses, you're going to distribute your 6. So we got 6 times x is 6x, plus 6 times h is 6h, and then we got our minus 4. So notice, I cannot do anything else to this. So this is now f of x plus h. So then we said we're going to plug into the formula. All right, so here's my formula. I got my f of x plus h minus my f of x all over h. So let me plug in for f of x plus h. That is 6x plus 6h minus 4. F of x was 6x minus 4. Now, you'll find shortcuts later in life on these. But I'm going to do what I said here. I'm going to drop the parentheses, and then I'm going to combine like terms on the top. So, dropping parentheses, you'll have 6x plus 6h minus 4. Now, y'all distribute the negative. So, negative 6x, and then negative times negative makes that a plus 4. All of that over h. So then we said, hey, all terms without an h will cancel out. Well, y'all look on top. The 6x and the negative 6x, they're going to cancel. This negative 4 and this positive 4, they're going to cancel. So notice, all that's left are the h's. You got a 6h over h. All right, y'all, let me see what my chat's saying. And that, good job, because the last step, divide all terms by the h. Well, those h's cancel out basically, and our final answer is 6. Okay? So y'all, that's the trick on these, okay? All right, so the second one is pretty much just like that one. So I'm going to go to number 3 now. So this one they're giving us 4 f of x equals x squared plus 1. Construct and simplify. The difference quotient. So I'll write it one more time. F of x plus h minus f of x all over h. So, first of all, find f of x plus h. So y'all, that'll be the f of x, put in an x plus h. So that's going to give us a x plus h squared plus 1. All right, y'all. So what we want to do here on the side, we got to figure out what x plus h squared is going to equal. Now, what's nice on these, if we figure out what x plus h squared is, anytime we get an x plus h squared, we can always replace it with this, okay? So save this, what we get for x plus h squared, save it because it's always going to be the same, okay? All right, so that'll be x plus h times x plus h. So we're going to FOIL that. X times x is x squared. X times h is a hx. I'm just putting them in alphabetical order. H times x is another hx. And then h times h is h squared. So we're going to add the like terms. So we bring down our x squared. 1 plus 1 gives me 2hx. And then at the end, bring down my h squared. So anytime we get this, we're replacing it with that. So this will equal x squared plus 2hx plus h squared. And then at the end is our plus 1. And y'all notice this. No like terms here. So that's going to be the f of x plus h. So we're going to plug into the formula. So my f of x plus h minus my f of x will all be over h. All right, so we're plugging in x squared plus 2hx plus h squared plus 1. F of x was x squared plus 1. Now, if you want to save yourself time instead of having to write this again, you can cancel this stuff at this point because that x squared and that negative x squared are going to cancel. This 1 and this negative 1 are going to cancel. So you can do it like that and save time. But y'all, I'm just going to go the long way. So I'm going to bring this first part down. X squared plus 2hx plus h squared plus 1 minus x squared minus 1 all over my h. Hey, also look what happens. The x squared and the negative x squared, the 1 and the negative 1 canceled. So I end up with a 2hx plus h squared all over h. So let's see what y'all got. Matt, you got a 2x plus h. So let's see. Here the h's cancel, and I'm left with the 2x. Good job. And that'll be plus. Here you got an h squared over h. So remember, you're basically subtracting exponents. This h would have an exponent of a 1 by it. 2 minus 1 left you 1h. Good job. And y'all, that would be your final answer. Okay, so notice everything in the second parentheses is always going to cancel out because these don't have h's on them, okay? So they're always going to cancel out every time. All right, y'all, let's knock out. What's next? Number 4. All right, y'all, this time we're given f of x equals. So this is going to be a little trickier. I got negative 5x squared plus 9x plus 2. All right, I'm going to write my formula here. All right, so what we got to find first is our f x plus h. So y'all, in place of both of these x's, we need to put an x plus h. So we got negative 5 times x plus h squared plus 9 times x plus h plus 2. Now, the only thing I'm going to work at this moment is figure out what x plus h squared equals. I'm going to work the exponent first. So I'm going to bring down that negative 5. Y'all, we know what x plus h squared is. We did that on the problem before. That gave us the x squared plus 2hx plus h squared. Everything else I'm bringing down. So all we did was replace x plus h squared with this. Now, to get rid of parentheses, we're going to distribute the negative 5 through the first parentheses, and then we'll distribute the 9 through the second parentheses, okay? All right, y'all, they get a little long at times. So negative 5x squared. Negative 5 times 2 is negative 10hx. And then negative 5h squared. Now we distribute the 9. 9 times x is 9x. 9 times h is a plus 9h. And y'all at the end is a plus 2. All right, so let's see if we have any like terms. And y'all guess what? No like terms. So this whole thing is now the f of x plus h. So we're going to plug in the formula. So I got it. F of x plus h minus my f of x. All of that will be over h. All right, y'all, so let's plug it in. So we got negative 5x squared minus 10hx minus 5h squared plus 9x plus 9h plus 2. F of x is a negative 5x squared plus 9x plus 2. Oh, y'all, I'm going to write all this and distribute this negative over here. But remember, at this point, all three of these are going to cancel with their counterpart over here, okay? So let's drop these parentheses. Negative 5x squared minus 10hx minus 5h squared plus 9x plus 9h plus 2. Now, y'all watch this. Negative times negative makes that a positive 5x squared. Negative times positive makes that a negative 9x. Negative times positive makes that a negative 2 all over h. But we said if it didn't have an h, it was canceling. So negative 5x squared, 9x, negative 9x, 2, negative 2. So now what you got? Negative 10x minus 5x plus 9. So let's see if she's got it right. Let me bring everything down. So notice the only three things I had the h's in them. All right, so here we go. The h's cancel on the first one, leaving negative 10x. All right, Nat, you're starting out good. In the middle, one h cancels, leaving one on the top. So that'll be a negative 5h. And then on the end one, the h's cancel, leaving me a 9. So y'all, that's all I'm doing on the last step is taking away one h from everybody on the top. So Nat, good job. And y'all, that's the trick on these. The biggest trick on these is to get the f of x plus h stuff. Once you get that, at this point, I can just cancel out the stuff that didn't have the h's in it and then divide those by h, okay? All righty, y'all, there's only one more, and this would be like number 5 here. Oh, yo, this is pretty small. They got an f of x equals 4x to the third. Okay, we're still doing f of x plus h minus f of x all over h. All right, so I guess the first thing we got to do is find f of x plus h. So that'll equal 4 times x plus h cubed. Well, y'all, we did x plus h squared. We don't have a cube yet, so over here on the side, we need to figure out x plus h cubed. All righty, so that's 3 of these being multiplied. So bring down that first x plus h. We know what 2 of these equal. 2 of those equaled x squared plus 2hx plus h squared. So that was 2 of them, but we got to multiply these, all 3 of these by both of these, okay? So y'all, we're about to have a lot of stuff here. So here we go. X times x squared is x cubed. X times 2hx is a 2hx squared. And then x times h squared is a h squared x. I'm keeping everything in alphabetical order to make this a little easier, okay? Now let's distribute the h times x squared is a h x squared. H times 2hx is a 2h squared x. And y'all, h times h squared is a h cubed. Now, y'all, the reason I keep mine in alphabetical order, this hx squared will add to these hx squareds, and this h squared x will add to this h squared x. So I'm going to bring down my x to the third. All right, 2hx squareds plus 1hx squared gives me 3hx squareds. 1h squared x plus 2h squared x gives me 3h squared x. And y'all, at the end is our h to the third. So y'all save this. Anytime you have an x to the h, x plus h to the third, you're going to replace it with that. So y'all, I got my 4 times x to the third plus 3hx squared plus 3h squared x plus h to the third. So we plugged in for x plus h to the third. Final step is to distribute. So let's see, 4 times 1 is 4x to the third plus 12hx squared. 4 times 3 is 12 h squared x, and then 4 times h cubed is a 4h cubed. All right, y'all, no more like terms because these exponents don't match on those. So this is f of x plus h. So now plug into the formula. So f of x plus h minus f of x all over h. All right, so let me see what you got going on there. So let's see. 4x to the third plus 12hx squared plus 12h squared x plus 4h cubed. And y'all, the only thing we're subtracting is f of x, which is a 4x to the third. So y'all, since I've only got the one thing being subtracted, it's pretty easy to see that the only things canceling are this 4x to the third and that negative 4x to the third. Everything that's left has a h. 12hx squared plus 12h squared x plus 4h cubed all over h. So let's see what you got there. 12x squared, 12hx, and then a 4h squared. So that looks good, Nat. Because 1h cancels, leaving 12x squared. Well, the h's totally cancel. In the middle, you had 2 on top, 1 on bottom. 1 cancels, leaving a 12hx. And then at the end, you had 3 h's. 1 cancels, leaving 2. So 3 minus 1 left me 2. So that'll be a plus 4h squared. So y'all, that's really the trick on these is to get that f of x plus h stuff. Now, save that for when you got an x plus h to the third. And then remember this part anytime you got an x plus h squared, okay? All right, y'all, let me see here. All righty, y'all. So any questions on that? So that takes us through all the material for test 2. So tomorrow is what, Tuesday? So tomorrow, guess what? We get to review for test 2. Okay. If we have time, I will start test 3 material, which will start with 8.1, and it's not a bad section. So our main thing though tomorrow, like I said, we're going to be reviewing for test 2, and that's 20 questions. All righty, y'all. Anybody got questions on this? All righty. Anybody got any homework questions that might be bugging you? And y'all, if y'all emailed me your bonus from test 1, I've added it yesterday. So y'all did actually really good on that test, okay? All right, y'all. So I will tell y'all for test 3, we're going to learn how to find zeros again. We'll do a lot of foiling. We're going to play with what we call synthetic division. And then it ends up dealing with rational functions and stuff like that. All righty, y'all. So play with that. So to be caught up with the class, you want to be all the way through 5.4 tomorrow so we can start knocking out that test 2 review, okay? All right, y'all. I'm not seeing any questions, so I will let y'all go, and I will see y'all tomorrow at 10 o'clock. And y'all have a good one. I'll see y'all tomorrow. All right, thank you, Nat. Good job.